5-4, multiplying polynomials, day 1. I'm going to take some time here and show you how we multiply monomial times a monomial, monomial times a binomial, monomial times a trinomial. We'll start with that today. After that, I have some examples to show you how we multiply a binomial times a binomial, and I'll do that 3 different ways. And then lastly, we're going to do a binomial times a trinomial. After I finish that, then I'll put down what I would like for you to practice on regarding multiplying polynomials. So let's start with the monomial times a monomial. You have 14a squared b times negative 3ab cubed. Since this is all multiplication, rearrange it mentally. So I'm going to do 14 times negative 3 times a squared times a times b times b cubed. So now 14 times negative 3 is negative 42. A squared times a, this is a 1 for the exponent here, so it's a cubed. And b times b cubed is b to the 4th power. So I have an answer of negative 42, a cubed, b to the 4th. That's a monomial times a monomial. All multiplication, multiply those that have the same base together, multiply your numbers together, and you get a single answer like this. Next, a monomial times a binomial. What we have to do is use our distributive property. We have to multiply 4x times both terms here. So I'm going to do 4x times 6x. I'll multiply my numbers. 4 times 6, 24. X times x, x squared. Now I'll take 4 times x times negative 7. I'll do the 4 times the negative 7, so I have a negative 28. And the x has nothing to multiply with, so I put the x right next to it. So I have a final answer of 24x squared minus 28x. My third example, when I'm multiplying here by monomials. Monomial times a trinomial. Again, we will distribute, and we'll do it to all 3 terms, like so. So I have negative 3ab times x a squared. Negative 3, the number in front of the x is 1, so I'll write negative 3. Here I have an x on the inside, but no x next to my monomial on the outside, so copy the x. A times a squared, a cubed. B times nothing, times actually 1, since there's no other b here, just copy the b. Now I'm going to redistribute to the middle term. Negative 3 times, and this will be negative 1, so that makes it plus 3. I have a y on the term on the inside on the trinomial, but not on the monomial, so copy the y. A times a squared, a cubed. B times what is 1, so I'll write down b. And now my third and final term, negative 3 times negative 5 makes that plus 15. There are no variables behind the 5, so I will just write behind it a, b. And none of these 3 terms are alike. This one has an x in it, none of the rest of them do. This one has a y in it, the other 2 do not. And in the last term, it's just ab, and the others have a cubed in them, so you cannot combine these for any like terms. This is my final answer here. So monomial times monomial, multiply those things that are alike and similar together, same bases. Distribute monomial to binomial or trinomial. If you have any questions, please ask me. All right, let's move to the next page. Now we're going to do binomial times a binomial. Now there's 3 different ways we can do this. 2 of the ways work with any type of situation, whether it's a binomial times a trinomial, binomial times a binomial. And the third way is a way that works only on binomials. So we're going to start with the 2 methods that work on any type of multiplication of polynomials. This first one, I have x minus 2 times x plus 8. I have 2 terms inside the first set of parentheses. So what I need to do then is I'm going to distribute x to x and x to 8. So x times x, x squared. X times 8 plus 8x. now I have a negative 2 times x right here. And then I have negative 2 times the 8. So I have negative 2 times x is minus 2x. And then I have negative 2 times 8 is minus 16. I have 4 terms in my answer. These two, plus 8x and negative 2x, they are like terms, so I will combine them. So I have x squared plus 6x minus 16. And my final answer is a trinomial because the 3 terms are all different. X squared, 6x minus 16. And I'll stop there. So again, one of the ways we can do it is just distributing things out. I can take x times both terms on the inside, then I'll take negative 2 times both terms on the inside. And that was what I showed you actually a minute ago here when I did a monomial times a trinomial or a monomial times a binomial. We just distribute this term to all the terms on the inside of the parentheses. So it's the same method I just showed you a minute ago. Another method that we have when we can use a binomial times a binomial or even any situation with multiplying polynomials is actually we can draw a box. We can draw a rectangle. And I'll show you how we do this. So I'm going to just draw a rectangle here. And after we get our rectangle put together, we have to take a look and say, all right, well, how many terms do I have in each of these? Up here, I have 2 terms. So I'm going to draw a box that the rectangle looks like this. Okay. So now I have my rectangle. And what I do then is I write the terms from the parentheses on top of a column or across from a row. And it looks like this, 3y minus 3. So now I will write 3y goes above one column. Minus 3 goes above the other column. So I have 3y minus 3. I brought that here to the top of the rectangle. And now I have 2y minus 7. So 2y will now go across from one row. Minus 7 will go across from the other row. And I'm now going to do some multiplying. I'm going to multiply each term on the top times each term on the side. So if I look here, 3y and 2y, when they cross in this upper left corner, so I'll do 3y times 2y. That is 6y squared. 3 times 2 is 6, y times y squared. I will now do negative 3 times 2y. Negative 3 times 2 is a minus 6. And the y I just write down because there's no y up here. It's only over here. I want to repeat that now for 3y and the 3 with now the negative 7. So 3y and negative 7 would meet in this box. 3 times negative 7 is a negative 21. And then I'm going to put a y. And now negative 3 times negative 7 would be plus 21. So I have now done all my multiplying. So now what I'm going to do is I'm going to work diagonally. If any of you ever remember the lattice multiplication that you did back in elementary school, this is following that same idea. So here's 6y squared. I'm going to write that right here, 6y squared. I put diagonally negative 6y and negative 21y. When I put those together, it's a negative 27y. And then this is the only regular number of plus 21. So now I have 3 terms here. I'm going to write my answer together. 6y squared minus 27y plus 21. All right. And either of these methods you can use. It's entirely up to you which one you use. If you like to use the rectangular method, that's fine. If you like to use this method where we're just distributing it, that's fine. Okay. The third method actually is very similar to the distribution one, but it actually has a name. The name of that is called FOIL. Okay. And what that is this. It's called first term for f. I multiply the first terms together. So x times x is x squared. That's f, first term. Then I have the O. The O stands for outside. So I have the x here and the 4z out here. And that's first outside, so I'm going to do x times 4z. That's 4xz. Then I have I for inside. I have negative 3z times x. That's going to be a negative 3xz. And I wrote these in alphabetical order. Use most of the time when we do our multiplying with our variables, we will write them in alphabetical order. Last, L stands for last. So now I multiply 3z times 4z. And that will give me a negative 12z squared. So I have first, x, first terms, outside, inside, and last. So I have x squared. And now I have 4xz minus 3xz, so that's going to be plus xz and minus 12z squared. FOIL is very similar to is actually like the distributing one on the first example, but the difference being foiling only works on a binomial times a binomial. Only works with binomial times a binomial. The rectangular method, doing the distributing, using the distributive property, works on anything. So let's look at the last example here. I have a binomial times a trinomial. And I can do this either way. I can distribute. I can say, all right, I'm going to do 2x times 5x squared, 2x times a minus x, and 2x times 1. So if I do that distributing, 2x times 5x squared is going to be 10x cubed. Then I do 2x times minus x is going to be a minus 2x squared. And then I have 2x times 1, so that'll be plus 2x. Now that means I've already distributed the 2x across all three terms. Now I must distribute the minus 3 to all three terms. So I'm going to do negative 3 times 5x squared. So it gives me a minus 5x squared. Then I have a negative 3 times a negative x. So that will be plus 3x. Negative times a negative is a positive. And then I lastly have negative 3 times 1. That's a minus 3. Now when I get done with my distributing, I have to combine the like terms. I have 10x cubed. And there are no other terms with an x cubed. So I will write down 10x cubed. I have a minus 2x squared. I want to look for other x squared terms. There's a minus 2x squared here, a minus 5x squared here. Negative 2 plus negative 5, negative 7x squared. The next term to deal with is a plus 2x. So I have this plus 2x right here. Is there another term with just an x in it, plain x? Yes, plus 3x. So I have plus 2x plus 3x. That is a plus 5x. The only term I haven't worked with now is the minus 3, and that is the only regular number there, so copy it down. So now I have a polynomial with 4 terms in it as my answer. 10x cubed minus 7x squared plus 5x minus 3. Or again, I could also use the rectangle method if I'd like to. And so I'll show you that one here. So I have this, and I'm going to draw this, and I'm going to draw here, and here. I apologize for the lines not being so straight. And since I have a binomial that I'm starting with, I'll draw a line, go down the middle, so I have 2 columns. And since I'm multiplying it by a trinomial, I have to have 3 rows. Now I want to write my numbers on the top. I want to write 2x up here, 2x, and I want to write a minus 3 here. And I want to write on the side, I want to write 5x squared on the first row. I want to write a minus x for the middle row. And I want to write plus 1 for the third row. And now I'm going to repeat my multiplying. So 2x, and you can just start on 2x. Where does 2x meet 5x squared? I'll multiply those together, and it's 10x cubed. And now I do negative 3 times 5x squared, a minus 15x squared. Go to the next row. 2x times a minus x is a negative 2x squared. 2x times a negative x is going to be a negative, oops, I'm sorry, my fault, negative 3 times negative x will be a positive. I got to get my handy dandy eraser out here. Okay. Sorry about that. So now I'm doing negative 3 times the negative x, so that, or the opposite of x. Negative times a negative is a positive, so I'm plus 3x. 2x times 1, 2x. Negative 3 times 1 is a minus 3. What you should notice in the boxes is you'll see the exact same 6 terms over here to where I did the distributing. Here's 10x cubed, it's over here. Minus 2x squared, it's right here. Plain 2x, it's right here. Okay, negative 15x squared. Uh-oh, did I make a mistake over here? I did. Mr. Ollenberg, what are you doing? Let's change that. This should be a negative 15x squared here, shouldn't it? I'll bet you caught that and wondered when I was going to catch it. So this should be a negative 15x squared. And let's rework my answer then. Negative 2x squared minus 15x squared. That's going to be a negative 17x squared. So my apologies for that. So I didn't mean to do that. And at this point, I don't want to stop the recording and start all over. So let's continue on here. But my apologies. I hope you caught that. If you did, great. All right, so let's go back now through our lattice method, and we're going to go diagonal. So to write our answer, so we have here, we have 10x cubed. Then you have negative 15x squared and a negative 2x squared, so that's a negative 17x squared. And then I have 3x and 2x, so that's 5x. And then I have the minus 3. And now I'll write my answer, and it should match. Now I have 10x cubed minus 17x squared plus 5x and minus 3. All right, so either way you do that, you're going to get the same answer. My apologies again for making the mistake that I made back on the first of the distributing here. I hope you caught it. All right, this video has gotten long enough. Here is the practice work that I'd like for you to do to get going with this. This is going to be on page 289, and we're going to deal with numbers 1, 3, 6, 8, 9, 10, 11, 17 through 22, 25, 49, and 50. So the assignment for you is right there. Stop the video, make sure you write that down, and then you can get going in your book. Thank you. Let me know if you have any questions, and I'll be happy to help you.